Hey, all right, day 2. What we're going to do today is go over some of the little theorems, okay? So the first one's called the side splitter theorem, and basically all it says is if you have a line that's parallel, right, it's never going to touch, it's parallel to a side of a triangle, and that line intersects the other two sides, then the line divides those two sides proportionally. So there were similar problems on your quiz on Friday that you took, actually. So look at problem 1. This line right here is parallel to that line. They've got those two arrows showing that they're parallel. So what it's saying is this line right here, if it's parallel to that line, then it divides these two pieces proportionally. So you could set up a proportion like 5 over 5. So 5 over 5 equals 7 over x. And then just cross multiply. But I'm guessing you guys already know what the answer is. So if these two pieces are equal, that would mean these two pieces are equal. But we'll still do the math. So we would get 35 equals 5x. Divide both sides by 5, and then x would equal 7. All right, which should make sense. Okay, the next one, we're going to set up a proportion. So think of like, I could think of this as my fraction line, x over x plus 12, and that equals 11 over. Now, if the whole piece is 33, this is 11, you've got to figure out how much this would equal. So if I would take 33 minus 11, I get 22. So I want to take a second and just have you look at those. Remember, you're always looking for relationships. Do you notice anything about the numerator and denominator? So this is twice as big as this, or that's half as much as that. So our final answer, this should be half as much as that. So now let's cross multiply and see what we get. We get 22x equals, and then this way, don't forget, you've got to distribute the 11 to the x and the 12. So that's 132. Okay, so now what I'm going to do is subtract 11x from both sides. So now I get 11x equals 132. Get x by itself, so I'm going to divide 11 by 11 and 132 by 11. So I would get x equals 12. Okay, so now I know if x equals 12, I could plug it back in. This side is 12, and this would be 24. So it works out. This is half as big as that. All right, good. So let's try the next one. Now this one looks a little different. We still have our parallel lines. I'm going to just do this. Remember, this you could think of as your fraction line. So I could put 6 over 18 if I wanted to. Now be careful though, if I chose the 6 to go on top, I'm going to match it up. This has to go on top. So then I would put x plus 2 over x plus 22. Now we're doing the same thing. All you're doing is cross multiplying. So I would get 6x plus, and that is 132, equals 18x plus 36. Okay, so I'm just multiplying everything. To get x by itself, I would subtract 6x from both sides. Okay, so now they're gone from here, and then I get 132 equals 12x plus 36. All right, so now I would get rid of the 36. I would subtract 36 from both sides. And I get 12x equals, now 132 minus 36 would be 96. Okay, so I'm going to divide both sides by 12, and I would get that x would equal 8. Okay, so this was just all algebra. So I could plug 8 in. So over here I get 8 plus 22, which would give me 30, and then 8 plus 2 is 10. So this is 1/3 of that, and this is 1/3 of that. So again, we're good. Okay, at any point you guys can stop, like pause the video and try it on your own. So let's try this one. Now, there's no numbers, so you have to fill them in. It's telling you that the distance from A to D is 15, D to B is 12, A to E is 10, and E to C is 8. So now you've got to figure out, are these two lines, is BC, is this segment, parallel to DE? So the way to do that is you're going to set up a proportion. So you could put 15 over 12 or even 15 over 10. Just like last week, it doesn't really matter necessarily the first fraction. So we would do, I'm going to do 15 over 12. So if I set it up as 15 over 12, then I have to put 10 over 8. Okay, now these have to be proportional. So you could cross multiply, you can simplify and see if they simplify to the same thing. I'm going to cross multiply, and this way I would get 120. And when I go this way, I get 120 also. So since they are proportional, they do equal each other, then yes, BC is parallel to DE. Okay, moving on. the triangle angle bisector theorem. Okay, so the angle bisector theorem says that an angle bisector of a triangle will divide the opposite sides into two segments that are proportional to the other two sides of the triangle. So it's a little bit wordy, but if you have an angle bisector, what that means is it cuts the angle in half, okay? So these are three other theorems that go along with that. The bisector divides an angle into two congruent, which is equal angles. So one of the theorems that goes along with this, if a point is on the bisector of an angle, it's equal distance. Okay, so equidistant is the same distance from the sides of the angle. So we'll show you that. The converse is basically saying it in the opposite order. If a point in the interior of an angle, it should say, is equidistant from the sides of the angle, then it is on the bisector of the angle. So you know if you have a point that's inside, right? It's inside of an angle, and it's the same distance from both sides of the angle, then it has to be on the bisector. All right, and then the last is like a little vocabulary word, incenter. The angle bisectors of a triangle intersect at a point called the incenter, and that is the same distance, it's equidistant, from the sides of the triangle. Okay, so let's do some practice. So this right here is your angle bisector. Okay, so I know that because of this. I know that at point E, I go to right here C, and I go to here A, and it has these marks on it. So since it has these marks on it, it's telling me that this is the same distance, excuse me, as this one is. So if these are the same distance away, then I know, so basically I could fold this on top of that. I know that these have to be congruent. So this angle has to be the same as that angle. So if this is 43 degrees, then angle ABE, that would have to be 43 degrees as well. So what this is taking the rules and seeing if you can understand, like from the picture, how to solve it. Let's try this one. So take a minute and look at, once you see that we've got a point on the inside of an angle where to get from A to Y and A to F, it's the same distance. So that's where equidistant comes in. You know then that this angle right here would have to be the same as this angle here. So angle YBA would also have to be 47 degrees. That's it. Okay? Now it obviously changes up a little bit. Let's look here. So now you got little markings that look like they're the same. So they're congruent. These angles are showing that they're congruent. So they're both right angles, which means that this triangle and this triangle are also congruent. So this has to be equal to this because it's that equidistant rule. I know that if this is my angle bisector, then 3x minus 8, my distance from here to here, has to be the same as my distance from K to M. So it has to equal 2x plus 1. And now all you're doing is getting x by itself. So I'm going to subtract 2x from both sides, so I get 1x. I'm going to add 8 to both sides, so I get a 9. So I get x equals 9. And that's it. Now we can plug it in and make sure. I'll plug it in here. 2 times 9 is 18. 18 plus 1 is 19. So my length is 19. 3 times 9 is 27. 27 minus 8 is also 19. So we're good. Sorry. All right. Next one. You've got these two, right? These are equidistant. You've got your right angle. So you know that this has to be the angle bisector. You know that since these two segments are congruent. So I know that these two angles have to be equal. Same thing again. 7x plus 5 equals 3x plus 21. I'm going to subtract 3x from both sides. So I would get 4x. Let's say I get rid of the 5 from both sides. 21 minus 5 is 16. So now I'm going to divide both sides by 4, and I get x equals 4. So now I'm going to plug it in. 7 times 4 is 28, and 28 plus 5 is 33 degrees. Moving over here, 3 times 4 is 12. 12 plus 21 is also 33. Yeah. So we did it. So we're all good. So angle EWL is asking for this angle in here, which was the 33 degrees from E to W to L. Okay, I hope you guys are okay with this. Moving on. The triangle midsegment theorem. Okay, so, sorry. What it is if you, here, I'll just first read this. the mid-segment connecting the midpoints of two sides of a triangle is parallel to the third side of the triangle. And the length of this mid-segment is half the length of the third side. So there's a couple things going on there. Basically, the mid-segment is always half the length of that last side. So if you look here, we've got this triangle. So this is side CD, right? CD would be parallel to which side? So we're just trying to see which, in this shape here, which side will it never ever touch? So obviously it touches all of these. PN is the side that it would be parallel to. So they're going in the same direction, they're never going to touch, so I'm going to put segment PN. So if these are parallel, and if these were midpoints, so let's say these are both in the middle of their respective sides, then this would be called a mid-segment. So let's look over here. So I see these two little marks. So since these markings are the same, I know that this has to be the midpoint. And then the same thing here. I see these double markings and these double markings. So since those are equal, this is the midpoint. So I know that this is my mid-segment. So the rule basically is saying this mid-segment is half the length of this, okay, of the side that it's parallel to. So I know that 2x minus 3 is, whenever you see is or here is, that means equals. It's half of this. So I'm just writing down what I said. 2x minus 3 is half of x plus 9. Okay, now I'm guessing you're not going to want to like distribute this 1/2. So what's one thing you can do to get rid of this? What I would do is multiply everything by the reciprocal, or by 2. Okay, so I'm going to multiply this by 2, I get 4x. This by 2, I get minus 6. And then when I multiply this side by 2, the 2 times the 1/2, or 2 over 1 times 1/2, that turns into 1. So I just get x plus 9. Now I'm just going to solve for x. So I can subtract x. So over here I would get 3x. I would add 6. So I get 15. Now I'm going to divide by 3, and then x would equal 5. So now I need to plug it in because I'm not sure this is right. Let's see. Okay, so 5 plus 9 is 14. 2 times 5 is 10, and 10 minus 3 is 7. If I were you, I would always plug it back in just to confirm that this ends up being half as much as that. Okay, so I'm going to show you a different way to do this one, and you might like it a little better. Okay, the way we set up the last one is I said that this is half as much as this, right? Well, another way to think of it is this is 2 times bigger than that. So I'm going to save us a step. I'm going to say 2 of these, so 2 times x plus 2 equals 3x minus 8, right? Because if this is half as big, that means I need 2 of them to end up equaling this. So now I'm already at this step. I can distribute. I get 2x plus 4 equals 3x minus 8. I want to get x by itself again, so subtract 2x, so it's gone from there. Subtract 2x, so I get a 1x. I had a minus 8, so I'm going to add 8 to both sides. Sorry, I'm running out of room. So I get x equals 12. Okay, again, check it, because let's say like you might have made a mistake here. A lot of people do. So when I plug in 12, I get 12 plus 2, which is 14 here. And I'll plug it into the bottom. 3 times 12 is 36, and 36 minus 8 is 28. Whew. All right, so we're good. Okay, so x is 12, and then it may ask you for either of these two segments. Okay, moving on. So now this picture looks different, right? So we have these two pieces and this one, which we haven't seen yet, but that's okay. We know that these two markings are the same, so definitely this is the midpoint, same as this. Okay, so I'm going to do this problem the same way we just did the last. I know that this is half of that, right? So if I would take 2 of these, then it ends up equaling this. Sorry. Okay, when I distribute, I get 2x minus 6 equals x plus 6. I'm going to subtract the x here, subtract it here, so I get 1x. Let's add 6 to both sides. And then 6 plus 6 is 12, so x equals 12. We'll plug it into all of these parts. So if x is 12, 12 minus 3 is 9. 12 plus 6 gives me 18. And then when I plug it over here, 12 plus 6 is 18 again. So you might be asked what the length of UJ is, or JT. So in that case, since 18 is the whole length, and you've got these two pieces, that means that j cuts it in half. So each of these guys would be 9. All right, are we okay? Okay, I hope so. This one here. So I want you guys to try this. If you want to pause, maybe, and then check and see what you get. I'm going to take this guy right here, the x plus 19, and multiply it by 2. So 2x plus 19 should equal x plus 29. So I'm going a little faster now. I get 2x plus 38 equals x plus 29. Okay, I'm subtracting the x from both sides. This is so much algebra. So I know you guys can handle this. So we get x. I'm going to get rid of the 38. Oh, negative. So 29 minus 38 is negative 9. Let's see what happens there. So plug it in. If I plug in negative 9 for the x, negative 9 plus 19 is 10. Okay, that's good. It's positive. Negative 9 plus 29 is 20. Okay, so we're still okay. So this is showing you could get a negative, value for x and still be okay. You just don't, something would have been wrong if you ended up getting a negative length. You don't want that. All right, moving on. This guy here, I'm going to take 2 times x plus 2 equals x plus 10. Okay, because once again, 2 of these would equal that, right? So 2x plus 4, you're just distributing, equals x plus 10. Get rid of the x from both sides. So I get 1x. Let's say I subtract the 4. I can do that if that helps. 10 minus 4 is 6. Toss it in there. 6 plus 2 is 8. 6 plus 10 is 16. This is half of that. So woohoo, we're good. Okay, so what I would say now after this video, you should be able to do the triangle side splitter theorems, level 1 and level 2. The triangle mid-segment theorem, which is what we just did. And then this one, try it. So I'm including a couple of the drawing ones. Just try it and see. You guys should be fine with it. And then the angle bisector. Okay, joke of the day. What animal is smarter than a talking parrot? Put your answers in Google Classroom. I want to know what you get. And then the answer from yesterday is this. Crackpots. All right, do something fun today. Miss you guys. Talk to you later. Bye-bye.